Okay, so we're still going to be looking at the quadratic formula today, but just like we did with completing the square, okay, sometimes when we simplify, we'll get a perfect square. Sometimes when we simplify, we won't. So still the same formula, still the same process, just today we get some other things that might happen in that process. I have pencils over there on the bookshelf too.
Just to remind myself to get a textbook.
Okay, so here we go. Number one that we're going to look at, how about, actually no, don't do it. 3x squared minus 11x minus 2 equals 0. Right? If we go down our list of all the different ways that we can solve quadratics, this is not going to fall into the list of anything else we've done. Right? Solving this as a square root isn't an option. Solving it by factoring, it's not going to be factorable. We could complete the square, but it's going to be very horrendous to divide by the 3 and have a b of negative 11/3. Okay, so quadratic formula is where this type of problem is perfect for. Okay, it's in the correct form. It's already set equal to 0. So what does A equal?
0.
3. What does B equal?
11.
Negative 11. What does C equal? Negative 2. All right, once we have A, B, and C, we are plugging into the exact same formula that you did yesterday. Hopefully, just after doing your homework, you're kind of like, oh yeah, I kind of can do the quadratic formula without even looking at it. Okay, so we'll say negative B or the opposite of B. So opposite of negative 11 is positive 11.
No, I could just have to write negative 11.
Do what?
You still have to write negative 11 now. That's because that's the formula.
Well, the formula says negative 11, negative B, but the negative of negative 11 is positive 11. Okay, plus or minus the square root of b squared, so negative 11 squared. Minus 4, because that's part of the formula, times A, times C, plus U, all over 2 times A. Then just like we did yesterday, right, we'll pick up our calculator and we'll type all the stuff underneath the square root in. And what do we get out? 145? No? 145, we're agreeing with me? I was just remembering what number we got earlier today.
I got 127.
Did you put your negative 11 in parentheses?
Mm-hmm.
Here, let me see. Tell me.
Minus 4 times 3 times negative
I
2.
put divided by negative.
Okay, make sure right here, this is a big problem. Make sure your fraction bar is going all the way across here. Okay, that dividing by 6 isn't just going with one piece. Okay, then our next step says to take the square root of 145. So if we use our calculators and we take the square root of 145, what do we get?
12 times 0 for 1.
Right, decimal, because this is an irrational number. It's not a perfect square. We don't round. We don't want to round. Okay, so since we want an exact answer, our only other option is then to simplify the square root. Right, we've already talked about how we simplify with radicals. So let's prime factor that 145. What number will go into 145?
5.
5. 5 and 29. Can we split up 5?
No.
Can we split up 29?
No.
So do we have any pairs?
No.
So this is just our answer. Okay, so our answer is x equals 11 plus or minus the square root of 145 all over 6. How many answers is that? 2. right? One is 11 plus the square root of 145 over 6, and one is 11 minus the square root of 145 over 6. Weird answer, but still two of them. Are we okay on that one? This is our best case scenario, right? We can't simplify the square root any further. There's nothing else to do or done. I guess the only other easy case scenario is what happens if we get a negative underneath the square root. No real solution, right? We said that yesterday. Let's look at another one. How about a squared plus 6a minus 4 equals 0. Is this in the correct form for the quadratic formula? Yes, Josie, sorry.
So if you're dividing by a negative, it's always going to be no real solution.
Not if you're dividing by a negative, if you have a negative underneath the square root. So if you get like 4 plus or minus the square root of negative 39. This can be negative, positive, whatever. It's this piece right here that can't be negative. Okay. Right, so this is in the correct form for the quadratic formula. Right, it's set equal to 0. Okay, so what does A equal? Yes, Maddie?
So the only qualification it needs to be set for the quadratic formula is it has to be set equal to 0.
Yep.
Okay.
And it has to have an exponent of 2, right? Otherwise it wouldn't be a quadratic. Okay, so what does A equal?
1.
1. What does B equal?
6.
What does C equal?
Negative 4.
Negative 4. And then we'll start plugging into our formula. So right, instead of saying x equals, this time it's A equals because it's a variable. So negative B, so negative 6 plus or minus the square root of 6 squared, B squared, minus 4 times 1 times negative 4. All over 2a, so all over 2 times 1. So then we'll type everything underneath the square root into our calculator. Right, again, like we said yesterday, if we weren't using a calculator, we would have to know that when we multiply this, right, 4 times 1 times negative 4 is negative 16. So subtracting negative 16 is really adding. Okay, but since we do have a calculator today, right, we can just type that in. We'll get negative 6 plus or minus the square root of 52.
Oh, yeah.
52.
Yes.
All over 2. Okay, then we're going to take the square root of 52. So if we put the square root of 52 in our calculators, what do we get out? Decimal. So this is an irrational number. Yes?
I'm just confused how we got 52 because 6 squared is 36.
Sure.
And then minus 4 equals 32.
No, order of operations. You have to do multiplication next.
Okay.
So 4 times 1 times negative 4 is negative 16.
Alright.
So that ends up
Yeah.
there. Okay, so this is irrational, which means we then need to simplify the square root of 52. So we'll start prime factoring. What goes into 52?
2.
2, sure. So 2 and 26. 26 we can split into 2 and 13. Do we have any pairs?
Yes.
Sure do. Okay, which means my square root of 52 can now be replaced with 2 square root 13. So I now have negative 6 plus or minus 2 square root 13 all over 2. Yes, Josie?
I don't understand why it's 13 since we're...
So right here when I prime factored this, it prime factored into 2 times 13. right? So my pairs come out in front one time, my leftover stuff stays inside.
Isn't 26 also a leftover?
No, because it still has a branch coming off of it, and we can't use anything that has a branch. So I'm kind of writing it weird because I wrote it out to the side, but right, if we did this, we would pick these three numbers, okay? Okay, now the last step here that we haven't touched on yet is that we can't forget our basic reducing math rules that we already know about fractions. We know when we divide by something, right, we divide every single term by it. Okay, outside numbers go together, but we can't mix it with inside numbers. So like this 2 can't be divided with the 13, but these all go together. Okay, so we need to look at all 3 of these numbers. We have to consider all 3 of them at once, and we need to ask ourselves, can we think of anything that will go into -6, 2, and 2? 2, right? We can reduce them all by 2. So if I divide these each by 2, I now have an answer that says -3 plus or minus 1 square root 13 all over 1. I just don't need to write down those ones. Okay, and this is then my final answer, and it's completely reduced and simplified. Okay, so when we were doing completing the square, right, we didn't have a whole lot of problems where we had to prime a factor and simplify the square root, because completing the square sort of takes care of itself in that original getting it set up in the right format. It just didn't happen as often. The quadratic formula doesn't have that, so we have a lot more of this that we need to do at the end. Okay, so making sure that we're getting it simplified completely. That's the piece that's kind of a pain in the rear with the quadratic formula. Okay, so let's look at one more here quickly. I know the bell's getting ready to, well, we still have a few minutes. I'm not gonna rush, but just to make sure we're okay with it. Let's say we had something that said 3x squared equals a -2x plus 9. Is this in the correct format for the quadratic formula?
No.
No. Right? It's not in the correct format because we don't have it set equal to 0. What could we do to set this equal to 0? Okay, option A is that we could subtract the 3x squared over here. What would be option B?
Subtract the 9.
Add 2x and subtract the 9. When we were solving by factoring, we wanted to keep the A positive, but when we're completing or doing the quadratic formula, it doesn't really matter. So you can go either way as long as it equals 0. Let's just say you decide to move this way and move both of them. You can move them both at the same time. Okay, so what's the opposite of a -2x?
Positive.
Positive 2x. And what's the opposite of a -9? Or
Negative 9.
Sorry, I told you the answer. So this becomes a 3x squared plus 2x minus 9. Okay, so let's start plugging this into the formula. So b is 2, so -2 plus or minus 2 squared minus 4 times 3 times -9 all over 2 times 3. What do we get underneath the square root? 112? So what are we going to have to do with that 112? Right? Start simplifying. So 2 and 56, 2 and 28, 2 and 14, 2 and 7. So 4 square root 7. So we'll have -2 plus or minus 4 square root 7 all over 6. What goes into -2? That will also go into 4. That will also go into 6.
2.
2. And so this will become -1 plus or minus 2 square root 7 all over 3. It's still a fraction. It's still 2 answers. It's still weird, but we are done.